This is how we see the network. Using topology diagrams, we can see the devices in the network, including end devices, such as desktops and servers, and intermediary devices, such as switches and routers. These diagrams may also contain detailed information about a device, such as the MAC address of the Ethernet and wireless NICs, IP or Internet Protocol address information, default gateway addresses, and addresses for the DNS server. By the way, don't worry about what these terms and addresses mean right now. All of this will be explained throughout this course. This is how we see the network. But how do devices see the network? You can think of it as every device being in its own bubble. The only thing a device knows is its own addressing information. In other words, this is how a device sees the network. It doesn't. So, how does a device know its IP address and what network it belongs to? How does a device know if the destination device that it needs to send information to is on the same network or another network? If the destination is on another network and the information has to travel through intermediary devices, how does the source device know where to send it next? How does the source device know if the information it sent was received or if it needs to resend anything that might not have reached the destination? The answer to all of these questions is protocols, the rules that govern how devices communicate. Most network communications are broken up into smaller data units, which we can refer to as packets. When packets are sent on a network, many protocols are involved to help them reach their final destination, each accomplishing a different task. There are protocols such as Ethernet and wireless protocols that physically connect the device to the network. The protocols DHCP and ICMPv6 provide IP addressing information, including IP addressing that tells the device what network it belongs to, the address of the default gateway that tells the device where to send packets that are destined for another network, and the address of the DNS server for when a device knows the domain name of a destination but needs the destination's IP address. For instance, when a user requests a web page from a web server, such as www.example.com, the device asks the DNS server for the IP address of the domain name www.example.com. IP is used to deliver the packet from the source of the information to its final destination, in this case the web server, similar to sending a letter. The web server will then respond back with the requested web page. TCP is a protocol used to guarantee reliability. In other words, to make sure all the information that was sent was received, such as the information that makes up the requested web page. If any of the IP packets don't make it to the destination, TCP resends them. So although we see the network like this, remember, it's a combination of many different protocols that allow devices to really see their place in the network and how to communicate with other devices.
Computer networks use protocols. Protocols are the rules that govern communications. Very similar to the protocols used in human communications. In human communications, we have protocols like language. If I'm speaking to somebody, we want to use a common language so we can understand each other. We may have other types of protocols that we use. Do we talk formally or informally? How we greet each other. There's a protocol for that. Even how we dress or conduct ourselves. All of this are protocols that help govern human communications. In computer networks, we use protocols also to help govern communications between two devices. For example, here are some common protocols. A computer message is actually made up of several protocols. In this message here, we have the Ethernet protocol. The Ethernet protocol governs network interface card to network interface card in the same network. We have Internet protocol. Internet protocol governs communication from the original source all the way to the final destination. Make sure the message gets there and gets there all along the way. These devices called routers know where the packet is going. IP is for that. There's TCP, Transmission Control Protocol. This protocol makes sure that the information gets there reliably. And if it arrives out of order, if there's a sequence of packets all associated with the same message, it makes sure that they get reordered properly. And then there's HTTP, Hypertext Transfer Protocol. This protocol governs the exchange or transfer of HTML, Hypertext Markup Language. So when we are requesting a web page or downloading a web page, the message can contain all of these protocols. So in computer networks, we use many different protocols. Learning about network protocols will give us a better understanding of how networks operate, how to implement and configure networks, and also how to troubleshoot networks. Successful communications requires the use of several protocols. So when a device sends a message, it is actually using several protocols. So here we have what is known as a protocol stack. In this example here, I am showing the TCP/IP model, which has different layers: the network access layer, internet layer, transport layer, and the application layer. So when a device creates a message, it is actually using protocols from these different layers. For example, this message over here, it is utilizing at the network access layer the Ethernet protocol. The Ethernet protocol is used for NIC card, network interface card to network interface card communications in the same network. The next protocol that's used is an internet layer protocol, IP. This can be IP version 4 or IP version 6. This makes sure that the message gets from the original source to the final destination, whether or not that message is within the same network or has to go across multiple networks. Another protocol that's used is a protocol from the transport layer. In this example, we're using TCP, Transmission Control Protocol. This makes sure that the information, the message, gets there reliably. Then the last protocol is from the application layer. In this case, HTTP. HTTP governs the exchange or transfer of HTML. So as you can see, sending a message requires the use of multiple protocols from the protocol stack.